Okay, this problem involves distributing 30 objects into 3 groups. So we have 30 books and we divide them into 3 boxes, 10 books per box. How many ways can we distribute the books if the boxes are numbered? So for example, books 1 through 10 can go in box 1, books 11 through 20 in box 2, books 21 to 30 in box 3, and that's different than the second line because the boxes are numbered. So this is a combination problem, and so the answer would just simply be 30 factorial over 10 factorial, 10 factorial, 10 factorial. We take the 30 objects and divide them into 3 groups of 10. So plugging into the calculator, we get 5.55 times 10 to the 12th, approximately. And actually the answer is, and I plugged this into Mathematica ahead of time to see what the answer would be, 996, 791, 340. And the answer is this very large integer. Okay, now so that's number 1. Number 2, how many ways can the books be distributed if the boxes are identical? In other words, it doesn't matter which one goes in box 1, which one goes in box 2, and which one goes in box 3. The issue is, which books go in boxes. And so these 2 arrangements would actually be identical. So there are actually 6 different ways of doing something like this. So we could have box 1, box 2, box 3. We could have 1 to 10 in box 1, 11 to 20 in box 2, 21 to 30 in box 3. We could also have the arrangement that's listed here, 11 to 20 in box 1, 21 to 30 in box 2, and 1 to 10 in box 3. There are 6 possibilities, 1 to 10 here, 21 to 30 there, and then 11 to 20. I could do 11 to 20 here, 1 to 10 here, 21 to 30 there. Finally, we could have 21 to 30 in box 1, 1 to 10 in box 2, 11 to 20 in box 3, 21 to 30, 11 to 20, and 1 to 10. So there are 6 different ways, so I've overcounted by a factor of 6 if the boxes are identical. So the answer to number 1 is this. The answer to number 2 will be the same number, 5550, 996, 791, 340, and we divide that by 6. So dividing by 6 on the calculator, it works out to be 9.25 times 10 to the 11th. If we actually use Mathematica to figure out what the answer is exactly, it goes like this: 925,166,131,890. And once again, there's no decimal point because there's some fixed number of ways that this happens. So the first answer is if the boxes are labeled so that the boxes are distinguishable. If the boxes are undistinguishable, then I overcount by a factor of 6, and so I have to divide by 6 to get rid of that overcounting.